it is worth noting again that the error in using, or the difference between the left-hand and right-hand sum for an increasing function is for each interval going to be the area of this little red and green triangle that we've seen in previous lectures. Now the total area of these little green and red triangles, if we imagine, remember that the widths here are supposed to all be the same. It's not exactly drawn that way, but that's just due to my artistic inability. If we stack these rectangles on top of one another, since each rectangle starts at the height that the last one left off at, we could imagine just sliding these rectangles over one at a time, and we get a stack of rectangles that's just from here to here. Okay, so the height of the rectangle is just going to be from this height to this height. That's what I've drawn over here. A rectangle whose lower end starts at the height of the very first rectangle, the left-hand sum for the very first rectangle, and ends at the altitude of the very last rectangle. Obviously, the altitude of this rectangle is f of b minus f of a. The width of the rectangle is delta t, so its area is nothing but f of b minus f of a times delta t. And that's what we have written here, f of b minus f of a times delta t. We'll zoom in on that a little bit. And again, this rectangle corresponds to the stacking of all the little rectangles, all the little errors, all the little differences between lower and upper sum over the whole graph. That's why the error, or the total difference between right-hand and left-hand sum, is just the area of this rectangle. And that, of course, is f of b minus f of a times delta t. That's no different than the result that we got down here. Okay, right hand minus left hand is all this, comes out to be f of b minus f of a delta t. But what we see here is a geometrical reason. The stacking of these rectangles gives us a rectangle of these dimensions, and therefore this area.